Hello, here we have our continued discussion of Chapter 3, Section 3.2. This is video number 2B. We are at objective number 3 of Section 3.2. So objective 3 is graphing a line given its slope and a point on the line. You can see in the notes it gives you the 3 steps you need to go through to graph a line given its slope and a point on the line. So you want to always plot the given point first, then use the slope to continue the line from that point. Always, then of course lastly, is connect your points with the straight edge. So the numerator is your rise, the denominator is your run. We are on page 178 in the textbook. Also discusses this a little bit. It also gives you the orientation of a line in the plane. So look at figure 18 on page 178. And our questions that we're working on are on page 184 to 185. And let's start with question number 47. So we're given that it's going to go through the point -4, 2, and our slope is 1/2. Okay, I'm trying to check that, but all right. So we are going to start at the actual coordinate point that we are given, which is -4, 2. So we plot that point first. So -4, +2. Okay, so here's our slope, 1/2. Rise, run. That means we're going to go up 1 over 2. It's positive, so we always go up. So up 1 over 2, up 1 over 2. You want to keep going till you fill in as much as you can of the graph, so enough coordinate points for you to connect the line. So up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, and continue that. And then I'm going to go down to the opposite direction also, just so I have as many points as I can. So then I take my straight edge and I connect the points and I am left with this graph. So there we go. We graphed number 47 starting at this coordinate point and using the slope. Next we have number 49. 49 is through 0, -2 with a slope of -2/3. Now it's negative, so it means I'm going to go down and over to the right. You're always going to the right starting from the coordinate point you're asked to start at. So 0, -2. So down 2 over 3, down 2 over 3, down 2 over 3. So I'm going downwards. That's what a negative slope is. But now I'm going to go up 2 over 3 in the opposite direction just so I can get enough points so that when I do my straight edge, it's nice and straight. And I don't have to worry about being off or having a squiggle line. And there is my graph for number 49. Next is number 53. Slope is 0. Remember, a 0 slope means it's horizontal, and it's going through to -5. So 2, -5. And a 0 slope, we said, is horizontal, so that means it's going to go this way. It's going to go straight through that point. So I am just going to take my straight edge, put my straight edge through that point, and I connect it. And there we have our line. So again, slope that's 0 is a horizontal line. And our last one, number 55, and this is on page 185, I have an undefined slope going through -3, 1. Now, undefined slope is a vertical line going up and down. So I go to -3, +1, and we're going to go up and up and down through that point. So I take my straight edge, put it right up and down through that point, and draw a line, and there we go. Okay, so that is objective number 3, graphing a line given its slope and a point on the line. Now our last objective, objective number 4 for section 3.2, is determining if a line is parallel, perpendicular, or neither using slope. So, the slope of a line is the steepness of the line. And parallel lines will always have equal slopes because they have equal steepness. You can find slopes of parallel lines on the top of page 179. Perpendicular lines are slopes that are negative reciprocals. So if they're negative reciprocals, that means they're going to form right angles to each other, and the slopes will there have a product of -1. So, bottom of page 179, you can also find some information about slopes of perpendicular lines. Okay, so our last few questions can be found on page 185, and we are on the bottom of page 185. So now the 3 questions give you a line passing through 2 sets of coordinate points, and then a second line passing through 2 coordinate points, for 57 at least. So what you're going to do is you're going to find the slope of each line using our slope formula, and then you're going to determine, is it parallel? Are the slopes the same? Is it perpendicular? The slopes are negative reciprocals of each other, or is it neither? The slopes have no relation to each other. So, looking at our first example, number 57, I first have coordinates 4, 6, and -8, 7. And my slope equation, remember, is change in y over change in x. Does not matter which direction that you do your subtraction in, as long as you subtract in the same direction. So I'm going to go from here to here, just to try to make it as easy as possible. So 7 minus, change in y, 7 minus 6. Change in x, -8 minus 4. 7 minus 6 is 1. Keep change. I get -8 plus -4. That is -12. So my slope here is -1/12. Okay, it doesn't matter what the slope is. All that matters is if it's parallel, perpendicular, or neither. Okay, now let's do the second set of coordinate points, which are -5, 5, and 7, 4. So I'm going to go same direction, just to make it easier. 4 minus 5, 7 minus -5. So keep change. I get -1. Keep change is 12. We discussed equivalent fractions. It does not matter where the negative sign is located, because it makes the whole fraction negative. So we have here same slopes, so that makes these 2 lines parallel to one another. And you can see that answer on the slide notes. Okay, our next one is number 61. Now at 61, I'm given 2 equations. So at 61, I'm going to use the information that I did back in, which one was it? Objective number 2, which was you find the slope given the equation of a line. So 2x plus y equals 6, and x minus y equals 4. So I'm going to rewrite both in terms of y equals. So minus 2x, y equals -2x plus 6. So my slope here is -2/1, minus x, I get -y equals -x plus 4. Divide everything by -1. I get y equals x minus 4. So now there is no number in front of x. Really, it's a 1. So my slope here is 1/1. Looking at the two slopes, there is no relationship between them, so we're going to call this one neither. They're not parallel and they're not perpendicular. So 57 was parallel, 61 is neither. And you can see that again in the answers in your notes. Our last question, number 67. Now 67 again gives you two equations. So 4x minus 3y equals 8, and 4y plus 3x equals 12. Be careful when you're writing your variables here. Okay, I am subtracting the 4x on both sides. I get negative 3y equals negative 4x plus 8. Divide each term by negative 3. Again, don't worry about the fractions. I get y equals 4/3 x minus 8/3. My slope here is 4/3 minus 3x minus 3x. 4y equals negative 3x plus 12. Divide everything by 4. I get y equals negative 3/4 x plus 3. And my slope here is negative 3/4. Okay? Looking at these two slopes, what's the relationship? This is 4/3, this is negative 3/4. They're negative reciprocals. Negative reciprocals indicate that the two lines are perpendicular to one another. And you can see that answer again in your notes. Alright, so that brings us to the end of the information that I wanted you guys to review on this day. It's to make up the classes that we missed back in January. You receive the notes in class. They can also be found on Blackboard. And this concludes video number 2B. Have a wonderful day, and I'll see you on Wednesday.